Hello, in this video I'll be working through problem set L-3a. First question is the limit as x approaches 1 of x over x squared plus 4. So to evaluate this limit, we can first plug things in and see if it gives us a divide by zero error. It turns out that it doesn't, because when we plug it in, the numerator is 1 and the denominator is 5. Sorry. And so the answer is just 1/5. And we don't need to do anything further. Question 2, the limit as x approaches 0 of x over x squared minus x. Okay, so when we plug in x equals 0, we're going to get 0 over 0. And so that tells us that we're going to need to do some simplification before we can evaluate this limit. So to simplify, we're going to factor the denominator, and the x's will cancel. So make sure you're continuing to write the limit symbol, the entire limit symbol. If you don't keep that, you're going to lose points. Remember, you only drop the limit symbol once you do the plugging in of the value 0. So before you plug anything in, as you're just factoring and doing manipulation, you have to keep writing the limit symbol. All right, so factoring the denominator factors as x times x minus 1, and the x's will cancel. So we still have to write it even after we cancel the x. And after the cancel, we're going to be left with 1 over x minus 1. And now we can plug in x equals 0, and we're going to get 1 over 0 minus 1, which is negative 1. Three, the limit as x approaches 3 of square root x plus 6 over x plus 2. Here we can just directly plug in x equals 3, right? And we're going to get square root 9 over 5, which is 3/5. Question 4, the limit as x approaches 4 of x minus 4 over x squared minus 16. So we're going to factor the denominator. Going to keep writing the limit symbol. The denominator factors as a difference of squares, which means the x minus 4's cancel. So now we can plug in x equals 4, and the answer is 1/8. Question 5. Here, if we plug in, sorry, I should have emphasized for question 4. When you plug in x equals 4, you're going to get 0 over 0. I kind of looked at it and just knew that would happen, so I didn't explain it, but that's what you should do first. So for this question, you should also recognize that if you plug in x equals 0, it's going to be 0 over 0. So we need to do some simplification first. And that simplification is just going to be factoring the numerator, which gives us, we can factor out x squared. And so that leaves 7x minus 1 over x, which means the x's cancel out. We're going to be left with x times 7x minus 1. And now you can plug in x equals 0, and you're going to get 0 times negative 1, which is 0. And that's the limit. Question 6. The limit as x approaches 5 of 5 minus x over x squared minus 25. If I plug in 5, I get 0 over 0. So that means I have to simplify. And so I'm going to factor the denominator, which is a difference of squares. And the numerator is just, this numerator here is just negative x minus 5. I can write that out more explicitly. So the x minus 5 cancels. I'm left with negative 1 over 10 when I plug in x equals 5 as my final step. Question 7. Limit as x approaches negative 3. All right, so what happens when you plug in negative 3? You're going to get 0 over 0. The numerator is going to be 9 minus 3 minus 6, 0. Denominator is 9 minus 9. That means I'm going to have to factor. The top will factor as x plus 3 times x minus 2. Bottom is x plus 3 times x minus 3. And so the x plus 3 cancels. And I'm left with x minus 2 over x minus 3. And now I can plug in negative 3, and I won't get a 0 divided by 0 error. And what that leaves me is negative 5 over negative 6, which is 5 over 6. I feel like I'm writing too small, so I'm going to make it thicker. Well, it's too thick, isn't it? Question, what did I just do? 7? 8. The limit as x approaches 2 of x squared plus 2x minus 8 over x squared minus x minus 2. You can kind of look at this and recognize that yeah, it's going to be 0 divided by 0. And so that means we should factor first. Top is x plus 4 times x minus 2. Bottom is x plus 1, x minus 2. And so the x minus 2's cancel. We're left with x plus 4 over x plus 1, which gives us 6 over 3, which is 2 in the end. Question 9. Here we have a compound fraction. So what happens when we plug in 0? We're going to get 0 in the numerator, because that's 1/3 minus 1/3, and 0 in the denominator. So that means we should simplify first. Let's first simplify the top. The top is going to simplify as 3 minus 3 plus x, in parentheses, over 3 times 3 plus x. You can use whatever method of simplifying fractions you like, as long as you get that. And this is all over x. So make sure you have a longer line there. Remember, you have to keep writing the limit symbol. So the numerator of the numerator reduces to 3 minus 3 minus x. So that's negative x over, and then the denominators combine because we're dividing twice, essentially. So that's going to be 3x times 3 plus x. So the x's cancel out, which means we're left with negative 1 over 3 times 3 plus x. And that is, now we can plug in x equals 0, and we'll get negative 1 over 9. Question 10, the limit as x approaches 0 of 1 over x plus 4 minus 1/4 over x. So this is same thing, 0 over 0. Numerator, well, this is really just the same exact problem, isn't it? Question 11. So here, delta x is a separate variable, okay? So it's not delta times x. Delta x is one big variable. Well, not big, but they're connected to each other. And this notation you'll see more when we do derivatives. Okay, so when delta x equals 0, this fraction is going to give us a 0 over 0. So we need to do some simplification. The top expands, right? And the 2x's cancel there, which means we're left with 2 delta x over delta x. Delta x's cancel, and so we're really just left with 2. And congratulations, you've done a derivative. Next question. So here, when we plug in delta x equals 0, we're going to get 0 over 0. Same pattern. So let's simplify. We are going to have to expand the numerator. So when we square it, we're going to remember our formula. A plus b squared is a squared plus 2ab plus b squared. So this is x squared plus 2x times delta x plus delta x squared minus x squared over delta x. So the x squareds cancel out in the numerator, which means we're left with 2x delta x plus delta x squared over delta x. And now we can divide both of the terms in the numerator by delta x, which leaves us with 2x plus delta x. And now we can directly plug in. As delta x approaches 0, this whole thing is going to approach 2x. That's the answer. 13. Here you can directly plug it in, and you're going to get 5 over 5, which is 1. If we plug in x equals 0, we're going to get 0 over 0. So that tells us we should simplify first. Let's factor the denominator. So that becomes 2 over x plus 3. And now we can plug in x equals 0, which leaves us with 2/3. For this question, you can just directly plug in, and there are no issues. And you're going to get root 9 over 4 minus 1, 3. So that's just 1. 16. For this question, you're going to get 0 over 0 if you do a direct substitution. And so that means we need to factor. The denominator factors as a difference of squares, which cancels with the numerator, leaving us 1 over x plus 3. And now we can plug in x equals 3. Question 17. Um, 0 over 0. So let's factor the numerator. 5x plus 2 over x. And so the x's cancel, and we're left with just 5x plus 2. Now we can directly plug in x equals 0, and drop the limit symbol. If you haven't noticed, 13 to 24 is really just a repeat of 1 through 12. Um, so if you feel like you're comfortable with 1 through 12, you really don't have to do any of this. I'm kind of wishing I didn't write so many questions, because I have to do all of them. Um, well, I don't have to, but out of the graciousness of my heart, I'm doing this. Um, okay, so this question, 0 over 0. So let's factor. I'm going to factor the top as negative x minus 1 to make the cancellation more clear with the denominator, which is a difference of squares, x minus 1 times x plus 1. X minus 1 cancels, which means that this is going to become negative 1 over x plus 1. And now we can plug in x equals 1, which leaves us with negative 1 over 2. Question 19. As x approaches negative 2, yeah, so if you plug that in, you are going to get 0 over 0. So let's factor. You're going to get x minus 3, x plus 2, over x minus 2, x plus 2. So that should become x minus 3 over x minus 2. And if you plug in x equals negative 2, then that yields negative 5 over negative 4. which is 5/4. 20. So the limit of x is approaching 3. X squared minus 2x minus 3 over x squared minus 4x plus 3. If we plug it in, we're going to get 0 over 0. So we should factor. That yields x minus 3 times x plus 1 over x minus 3, x minus 1. So the x minus 3's cancel out. And so when we plug in x equals 3, we're going to get 4 over 2, which is just 2. Question 21. Limit of x approaching 0. One over 2 plus x over 1/2 over x. This is the same as questions 9 and 10, essentially. So I'm not going to talk. Okay, 24 looks a little more challenging, so I'll talk. If you plug in delta x equals 0, you're going to get 0 over 0. And so that means we should simplify. If we expand the numerator, this is what we'll get. X squared plus 2x delta x plus delta x squared. That's the expansion of the first square. Then x plus delta x. Then let's distribute the negative sign over the next term. That'll give us negative x squared minus x. This is all over delta x. Let's cancel what we can. What cancels out? X squared, x, and x. So those things cancel, which means that we're left with 2x delta x plus delta x squared plus delta x over delta x. And if we simplify this, we are going to get 2x plus delta x So I'm just dividing each one of these terms here by the delta x in the denominator. 2x plus delta x plus 1. And now we can plug in delta x equals 0, which leaves us with 2x plus 1. Okay,